Hi, I'm Dr. Incognito. In this video, we're going to integrate trigonometric functions. There are two forms that I would like to integrate. The integral of sine to the power m times cosine to the power n, and the integral of secant to the power m times tangent to the power n. So powers of sine and cosine, and powers of secant and tangent. So first let me give an overview of the method. Many problems that can be broken down into these forms can be integrated using U substitution. So that's the overall method, U substitution. And more specifically, problems that involve the following forms: odd power of sine odd power of cosine, odd power of tangent, and unfortunately, even power of secant. Problems that involve any one of these four possibilities can all be solved doing a U substitution with the following scheme. U equals the other trig function. So for example, if we have a problem that has an odd power of sine, then that's in the sine-cosine camp, and the other trig function would be the cosine. So if we have an odd power of sine, the substitution that will solve the problem is U equals the cosine. If we have an odd power of tangent, then the substitution that will work, the other trig function would be the secant. Secants and tangents go together. So odd power of tangent, U will be the secant. Similarly here, odd power of cosine, U will be the sine, and even power of secant, U will be the tangent. So a couple of formulas that are going to be necessary when we do our U substitution. One of them is, for the sine-cosine problems, sine squared plus cosine squared is equal to 1. And for the secant-tangent problems, 1 plus the tangent squared is going to equal the secant squared. These formulas will allow us to transform back and forth between powers of tangent and powers of secant. And then whenever you're doing a U substitution, you have to calculate du as well. So we're also going to need the derivatives of sine, cosine, secant, and tangent. So just to recall, the derivative of sine x is cosine x. The derivative of cosine x is negative sine x. The derivative of tangent x is secant squared x. And the derivative of secant x is secant x times tangent x. So we need those four basic derivative formulas as well. Because whenever you're saying U equals a function, to calculate du, we need the derivative. So let's do an example. Let's take the integral of, let's say, sine cubed x times cosine to the fourth x dx. So this one fits into the category of, we have an odd power of sine x. Odd power of sine. So this is an odd power of sine. So the way we will solve it is with a U substitution. U equals the other trig function, which is the cosine. U equals cosine x. And so therefore du is negative sine x dx. The derivative of the cosine is negative sine x. Okay, now the problem is that we're not really ready to implement the U substitution immediately. So what we have to do is we have to manipulate this a little bit so that then we can use the U substitution to get something meaningful. And the way we do that is as follows. The du is negative sine x dx. So I'm going to take this sine cubed, and I'm going to write it as sine squared times sine. And now this sine x dx will give me, well, not exactly du, it'll give me negative du. This right here is negative du. Now, what I have left here, I would like that to involve only u. So I'd like that to be, just have cosines in it. For example, cosine to the fourth would be u to the fourth. But this one here is sine squared. It's not a cosine, it's a sine. But fortunately, thanks to this identity, sine squared plus cosine squared equals 1, this sine squared can be written as 1 minus cosine squared. And so 1 minus cosine squared x times cosine to the fourth x times sine x dx. Now we have a situation where the u substitution can be implemented. Everything here will turn into u's, and here we have negative du. So we can do the u substitution now. So this is going to be 1 minus u squared times u to the fourth times negative du. I'll put the negative there. Negative du. And this one is now easy to integrate. We could integrate that by just multiplying this together. We get a polynomial. So this would be u to the fourth minus u to the sixth. U to the fourth minus u to the sixth. But there's a negative there. Let's bring that in as well, actually. It'll switch the subtraction. We'll get u to the sixth minus u to the fourth. That looks a little nicer. And then we integrate, it's u to the seventh over 7 minus u to the fifth over 5 plus c. And the final answer is, what was u again? That was a while ago. Cosine x. So cosine to the seventh divided by 7 minus cosine to the fifth of x divided by 5 plus c. Okay. Well, I guess I'll just close actually by saying that problems with odd powers of tangent and odd powers of secant can be done using this the same ideas. U will equal the other trig function, so you'll calculate du, and then you'll take the original expression, and whatever du is, you'll split that off from the original expression. You'll take it and you'll put it off to the side, and you'll be left with a little bit less of the two functions that you had. We had sine cubed, now we're down to sine squared. But then you should be able to convert into whatever one was u. U was cosine, so sine squared times cosine to the fourth, we convert into all cosines, because sine squared is 1 minus cosine squared. So for the secants and tangents, this is your conversion equation here. Okay, so this method will work in these 4 situations. Okay, I hope that was helpful. Thank you for watching.